Okay, welcome to the class, and we are going to learn about reference signals, which are basically the pilot signals, and pilot signals are the signals which are known to the transmitter and to the receiver. Okay. Before we get into understanding these reference signals, that is the agenda of today's class. Let us recapture whatever we studied in the last class. So, we saw that capacity increases linearly with SNR at low SNR values. Then capacity increases logarithmically with SNR at high SNR values. Okay. Crucially, what we saw was multiple receive and transmit antenna system have same capacity provided transmitter has the channel knowledge, exactly the same capacity. Okay. And where we stopped in the last class was basically we took this two antenna system, okay, and then we took this two antenna system and we saw that basically if H1 and H2 are known at the transmitter, okay, which is a very important assumption, then what is transmitted from first antenna is H1 star by root C, okay, which is basically a scaled version of X, and H1 is the channel from first transmit antenna to the receive antenna. Okay. So, this is being transmitted from the first transmit antenna and this is being transmitted from the second transmit antenna. Okay. So, this is basically called the precoding. Okay. Why precoding? Because this processing is happening, this and this processing is happening before the signal is actually transmitted. Okay. And what is this C? C is basically calculated so that the transmit power constraints are not violated and the transmit power is always P. Okay. So, how did we calculate C? We basically calculated the power from first antenna and we calculated the power from second antenna and added both of them. That comes out to be this, okay, right, simple square of this signal plus square of this signal and you get this, okay, right. We set C as H1 square plus H2 square, okay, right. And then if you look at this, what is H1 square plus H2 square? If we denote H as basically this, okay, right, this is the vector H. So, what is norm of H? Right, okay. So, what is coming in the denominator, okay, where this, what can I write here? What is this root C? Root C is basically norm of H, okay, right. So, what is being transmitted from first antenna is H1 star by norm of H, and similarly what is being transmitted from second antenna is H2 star by norm of H, right. This is the signal being transmitted from two transmit antennas. Okay. Now, if this is transmitted from first antenna and this is transmitted from second antenna, okay, they get added on air. That is what is happening over here. Okay. X1 tilde from first antenna gets multiplied by H1, X2 tilde from second antenna gets multiplied by H2 plus noise, okay, right. And if we substitute X1 tilde and X2 tilde, which are basically this, you get this, right, okay. Now, what is the SNR? Signal power divided by noise power, and that is what you get. Okay, this is exactly the same SNR as what we see in the multiple receive antenna case, okay, with single transmit antenna. And what is happening here? That transmitter knows the channel, and with that it does not matter whether there are multiple receive antennas or multiple transmit antenna, okay. But the crucial part is that this transmitter should know the channel, okay, and we know that how important this information is at the transmitter. Without this, there will be a massive loss if there are multiple transmit antenna when compared with multiple receive antennas, okay. Now, in order to get this knowledge, this channel knowledge at the transmitter, we use pilot signals, okay, right, and that is the idea, that is the concept we are going to learn today, okay. So, 5G uses three different kind of pilot signals. One is sounding reference signal, other one is channel state information reference signal, third one is demodulation reference signal, fine, okay. So, we will discuss what is the use of each one of them and how they are employed in a 5G system, okay. We will take this example whatever we discussed just now and then we will see the use, okay. So, what is happening where this multiple antenna G node B 2 transmit antenna is transmitting to a single antenna user, right, okay, and it wants to precode the signal base station has to basically precode the transmit signal. Okay, that's what we saw in order to realize these the gain which are possible due to multiple transmit antennas. Okay. Now, before base station can do this precoding, it faces two problems. Okay. And what are these two problems? Okay. So, what this bullet says is this GNB faces two problems before it can precode PDSCH. What is this X? X is basically the data which needs to be transmitted, okay, and data is PDSCH which needs to be transmitted. Okay. Now, GNB needs to estimate this channel, right, okay, and then it needs to know the MCS also, correct. Then without that it cannot transmit, without it doesn't know what precoder to use and it doesn't know what MCS to use, okay, right, okay. So that's these are the two problems which the base station faces, okay. One is this transmit channel information, other one is the MCS, okay, right. So we'll see that how these two problems are resolved, okay, and this is basically done using these pilot signals which we just transmitted, okay, which we just saw, okay. So first assumption in order to help us out with this channel estimation, okay, right, we assume that the G node B operates in TDD mode, okay, where it can easily infer this downlink channel from the uplink channel, okay, right. So this is repeated. So this is, what is this TDD mode basically? So if you look at it, TDD mode is wherein a part of the slot is allocated for downlink, another part of the slot is allocated for uplink, okay, and they operate in the same spectrum, okay, same 100 megahertz spectrum, okay. So the base station switches from transmit mode to receive mode, okay. So when it is in the uplink mode, what happens? The UE is transmitting and base station is receiving. So that's base station is in the receive mode, and then when it has to transmit to the user, base station is in the transmit mode and the user is in the receive mode, right, okay. So base station has to switch, okay, but what is happening here is that for uplink and downlink, same 100 megahertz band is used, okay. So you can assume that the channel in uplink direction, which is this, H2, okay, this is the uplink direction, okay, right, and so this is the downlink direction, okay, right. So because same spectrum is being used, one can assume that these two channels are same, okay. Now if base station knows the channel in this direction, okay, right, in the uplink direction, and because it is operating in TDD, downlink channel can be assumed to be same as the uplink channel. That's an assumption we are making, okay, right. Now, but then base station needs to estimate this uplink channel, correct, okay. So once it has this uplink channel, the downlink channel can be assumed to be there with the base station. Now the question is, how does the base station estimate this uplink channel, okay. That's the first reference signal which I will teach you, which is used by the base station to estimate the uplink channel, okay, before it can precode in the downlink, and this reference signal is called the sounding reference signal, right. Sounding is basically you are basically sending something in the uplink, and with that you are trying to find out what is exactly the channel, okay. So the notion of that sounding is sending something to find out something, okay. What are we sending? Sending the pilot signal to find out the channel, okay. So now how does this sounding reference signal work, okay. So that's what I am going to tell you. First, let's say for estimating the uplink channel, we are looking at the uplink now, okay. Now UE will transmit a pilot signal, I am calling this as X, okay. This pilot signal I am calling as X, and this pilot signal is called sounding reference signal. So the pilot signal which is transmitted by the user in the uplink to estimate the uplink channel, okay, is called the sounding reference signal, okay. So how does this work? This is the signal which is being pilot signal, correct, which is being transmitted by the user in the uplink. Now if you look at the uplink, how many transmit antenna and how many receive antennas are there? There is only one transmit antenna and two receive antennas, okay. So if x is being transmitted, what will be received at the receiver, first receiver h1 x plus n1, what will be received at the second receiver h2 x plus n2, okay, right. And now that is what I am writing for you. What is the received sounding reference signal at the G node B? Y1 will be h1 plus x1 plus n1, okay. Now what have I done here, okay? If x is, to make our life easy, if I set x as 1, because this is a non-pilot signal, correct, okay, right, I can set it to anything, 1 minus 1, okay, right. So what am I doing here? So this is a received signal at first antenna, this is a received signal at second antenna, okay, and for the sake of convenience I have set x as 1 because, okay, because it is a pilot signal and it is known both to the transmitter and receiver. So if it is set x is, we set x is equal to 1 as transmitter, what will be received here is y1 is h1 plus n2, what will be received at antenna 2 is h2 plus n2, okay. Now look at this, what is this? y1 and y2 are basically the estimates of channel h1 and h2, right. Now why am I calling it as an estimate? Because it is not the actual channel h1 and h2, they are noisy versions of h1 and h2, right, okay. And if you do a course on estimation theory, it is called, they are called the least square estimates of the channel, okay, right. By transmitting a very simple pilot signal which is given a name sounding reference signal, okay, base station is able to estimate the uplink channel, right. And why are we looking at the uplink? Because it is very easy for the receiver to estimate the channel, correct, okay. Now base station has become the receiver in this case, this is a base station, and now base station has the uplink channel, and what assumption we are making? The base station operates in the TDD mode, right, and uplink channel and downlink channel are same in this, correct, okay. So it has, base station has estimated the channel in the uplink direction, now it knows the channel in the downlink direction also, because both of them are the same, essentially the same, right, okay. So that is an advantage, okay, that base with the SRS, base stations operate in the reception mode and it is able to estimate the complete uplink channel, okay, right. Now when it has to precode the signal, with this information it can precode the signal, and that is what it is going to do, right. So here what we are saying here is that you can assume the noise to be low so that these estimates are good, just for clarity, right. And if the noise is high, you will have to live with this estimate, then there is a noisy estimate, okay, right. But what the point we are trying to make here is the base station has the channel information now, okay, and with that it can precode the signal. Let us see what it does, okay. So, right, so this is basically now what will happen here. It has the uplink channel and similarly it has the downlink channel now. It will precode, that is all, okay, right. That is the, so first problem of knowing the downlink channel is solved, right, because once it estimates the uplink channel, downlink channel information it already has, okay. Problem number 1 solved, okay. Now problem number 2 is basically it needs to know the MCS also, correct, okay, fine. How will base station solve that problem? And that is the problem we are going to discuss next, okay. Let us see that, and in order to solve that problem, base station uses something called CSIRS, okay. That is second pilot signal I am going to teach you, okay, right. So what is this CSIRS? Okay, it is the downlink pilot signal which is used by the base station to help the user in estimating the MCS, okay, right. And let us see how that is done. So the problem here is, what we are trying to solve on this slide is, GNB needs to know the MCS using which it can send the PDSCH, okay, right. Now it knows the downlink channel, correct, okay, and it essentially knows the precoder which it has to design using this downlink channel information it has, okay. If you remember what precoder we used a specific precoder, okay, right, and the same precoder we are going to use now, okay. So what it does is basically in this case, okay, so GNB transmits this CSI RSX from both these antennas, okay, and precodes it using the same precoder. Which precoder? Which it will use for the data, okay, correct, okay. And in order to design the precoder, it already has the downing channel information, okay, right. So, what was the precoder we used in the last slide? You remember, okay. So, what was being transmitted from first antenna? We call this as x1 tilde. What was that? h1 star by, I said, norm of h into x, because this was the c which was coming in the denominator, right, okay. What was transmitted from second antenna? x2 tilde, that was h2 star by norm of h, correct, okay, right. So, and what are we saying here? Now, earlier we considered this as data with some x, okay, correct. Now, what I am saying here is, this is a CSIRS which is being transmitted, okay. And then this is because this is a reference signal, this is known to the receiver also, that is the fact, okay. Now, we are using the same precoder to precode this pilot signal also, okay. If x is a CSIRS, I am using same precoder what I used earlier for data, I am using it to precode the pilot signal also, fine, okay, right. So, if x1 tilde is a precoded pilot signal from first antenna and x2 tilde is the precoded pilot signal from the second antenna, correct, what signal this UE is going to receive? Okay, let us write it, I have written it directly, but what is this signal be? Y will be h1 into x1 plus x1 tilde, sorry, h2 into x2 tilde plus noise, correct, okay. And what is x1 tilde? This, right, you substitute x1 tilde and x2 tilde here, what do you get? You get this, correct. And what is this? Can I write it like this? If I define h as, what is, okay, now what is, even if we do not define, what is happening here? What comes in the numerator? What comes in the numerator? How can we write this? h1 square plus h2 square by norm of h into x plus n, right. And what is this? Right, norm square, this gets cancelled and you get this, that is what I am writing over here, okay, right. Now, what happens here, okay, what will UE do, okay, this is the signal it has received, okay, correct, and this is the noise, it will calculate the signal power, it will calculate the noise power, fine, okay. And this, so what will the, it will calculate the SNR, that is what I am saying over here. What will the SNR? H square P. And what will the noise power? Cannot, correct, okay. Now, if it knows this SNR, how will it calculate the MCS? Log 1 plus SNR, right, okay, correct. And if it, now it will be one of those MCS values which are there in the table, right, okay. And how will it feed it back to the base station? What will it do? It will feed it back using either PUCCH or PUSCH, okay. There is a control information which needs to be transmitted by the user to the base station. And what are two different ways of doing it? One is, if PUSCH is not being transmitted, then it will send it using PUCCH, correct, okay. And if PUSCH is being transmitted, it will multiplex this control information on the PUSCH and then send it, correct. So, what was the second problem? Second problem was base station needs to know the MCS, and using the CSIRS, base station has helped the user in estimating the MCS, and that is the job of CSIRS. once the MCS is known to the user, it uses the control channel to feed it back to the base station, right? Okay. Now base station is all set to transmit the PDSCH, right? Okay. You see the problem, okay, correct? Before it could even start thinking of transmitting the PDSCH to the user, it needed to know the channel so that it can precode that information PDSCH, okay, and which channel? Downlink channel, right? And it needed to know the MCS. Now to solve that problem, the first assumption we made was that base station operates in the TDD mode so that it estimates the uplink channel using SRS, correct? That is the solution of first problem. Solution of second problem is basically, what was the second problem? That it still does not know the MCS, okay? And how did it solve the second problem? That is what we are discussing. It transmits the CSIRS, which helps the user in estimating the MCS and feed it back to the base station, okay? Now the key thing over here is that you look at this, what is user finally receiving? This signal, right? Okay. It does not even know how many antennas base station is using to transmit the signal, because what is finally base station user receiving? User is receiving a scalar signal, okay, correct, and these signals get added on air and user receives a signal, a single scalar signal, okay. How does it matter if I put one more antenna over here? User is still going to receive a scalar signal, and how will the scalar signal look like? It will look exactly the same like this. What will I transmit from let us say I call this third antenna, okay, I will transmit, if this is a channel H3, what will I transmit from here? H3 star by norm of H, and what will, let us say I define H as H1, H2, H3 in this case, correct? User does not know how many antennas base station has used to transmit this signal, correct, okay, right. So that is one key aspect, okay. Now this CSIRS is used in multiple ways in 5G. This is one way in which this CSIRS is being used, okay, right, to basically help the user in estimating the MCS, okay. But another key thing is that user does not know how many antennas base station has used, okay, right. Now, so what we have learned here is basically the use of two different pilot signals, okay. One is SRS in the uplink, then CSIRS in the downlink, okay. Now what we are left here is basically the use of, there is a third pilot signal which is DMRS, okay, and this is called demodulation reference signal, okay. So if you look at this CSIRS, this is also being transmitted in the downlink, correct, okay. Now what is this DMRS? This is, in this case, it is also being transmitted in the downlink, okay, right, but it is transmitted when PDSCH is scheduled. What am I saying here? CSIRS was transmitted before PDSCH was being sent, before actual data was being scheduled, okay. Job of CSIRS was to help the user in estimating the MCS. Actual data was not being sent, correct. Now base station is all ready to send the PDSCH to the user, right. Now it sends this DMRS, okay, along with data to help the user basically demodulating the data. How it happens, we'll see that, okay. Now the thing here is, okay, the user needs to estimate the channel before it can demodulate its data, okay. Just for an example, okay, right, that if, why it needs to know the channel? Because let us say QPSK is being transmitted, okay, right. This is a modulation, this is a constellation, correct, okay. Now if the channel is such that it rotates the constellation, okay, or it scales the constellation, okay, let us say it rotates the constellation, right, okay. So what happens here? The user will have to, if the constellation gets rotated like this, it becomes like this, okay. The channel was such that it rotated the constellation. User needs to rotate it back. It needs to know the channel. Correct? Okay. How will it estimate the channel? That's the part I am trying to teach you here. Okay. So UE needs to estimate the channel before it can demodulate the data. Okay. So this GNB transmits a pilot signal P from both the antennas and precodes it also. Okay. Right? And what is this? Again, okay. So it sends this pilot signal P, it sends this pilot signal P, right? Okay. Correct. And what precoder it is using? It is because what channel information it has? It has this channel information that the channel is H1 from here and H2 from here. Okay. Right. So what it does here is, again it uses, so what it transmits from here is H1 star by norm of H. Okay. What it does is here is H2 star by norm of H. And what will be received at the pilots, what will be received at the user? If this is being transmitted, I call this as, let us say, P1, I call this as P2. What will be received at the user? It will be H1P plus H2P plus N, right? So H1P1 and H2P2 plus N. P1 is the signal being transmitted from here, P2 is the signal being transmitted from the second antenna. Okay, right? Now, if you substitute P1 and P2 from here, you get this. Correct? Again, so what will happen here? What is coming in the numerator? H1 square plus what comes here? P by norm of H, right? Okay, plus N. And what do you get? What is this? Norm of H into P plus N. Okay, right? If you set this P as 1, what happens here? What is there in Y? You get this combined channel, right? Okay, and this pilot signal is called the demodulation reference signal. And the same idea is applicable for 5G system when GNB uses 64 transmit antenna. I just gave you an example of 3 transmit antenna in the last case, okay. But if there are 64 antennas, you are going to, UE is going to receive this same received signal, correct, okay. And this is the channel which is observed by the user when the PDSCH is transmitted, okay, right. And now you could ask me this question. It's the same, essentially the same. What is happening for CSIRS and what is happening for DMRS is essentially the same. In the first case also, UE has this norm of H. In the second case also, UE also has norm of H. What is the difference? Okay. Idea is this. Okay. Now we have to understand this fact that the CSIRS was transmitted initially to get the estimate of the MCS, right? Now this user estimates this MCS, then it feeds it back to the base station through this uplink channel. There is a delay, right? Okay. Then base station also does not use it immediately, okay. It schedules this PDSCH after some delay, right? So it could happen, and it generally happens, that user has transitioned from one place to other. User has moved slightly, okay, right? Then the channel has changed little bit, just for example. Okay, if you move from here to there, okay, channel would have changed a little bit. Now, whatever information on which this MCS was generated, okay, is slightly different from the actual channel when the PDSCH is scheduled, right? Okay, correct. So you can say that this MCS information was calculated using slightly old channel information, right? Okay. So what, and then when the actual data is scheduled, channel has changed slightly. So you could ask multiple questions, that why use this old channel MCS information, because that's the best you can do. Okay, this is the loop wherein like user has to first estimate the MCS and send it back. Okay, and it is not guaranteed that the turn of this user will come immediately for PDSCH information transmission. There could be some delay, and typically there is a delay. Okay, right? So what base station does is, whatever MCS information it has, okay, basically it does not transmit at that MCS, it uses a slightly lower MCS, okay, right. So, that just to ensure that the rate which has the MCS which user has asked, it basically takes some, it tries to guarantee that by using the lower MCS, okay, that the data transmission, the user will be able to decode the data correctly, okay. Because it is asked for a higher rate, base station is transmitting at a lower rate, right, okay. So, that is how MCS is being used. Now, while decoding the data, it helps the user by sending the DMRS so that it has exact channel information, right, okay, correct. And how does this exact channel information come? By sending the DMRS, right, okay, because this is transmitted, this DMRS is transmitted along with data, okay, and that is the fresh channel information, okay, right. And you will see this, okay, this H, okay, this is the latest channel information, but along with this data has come, okay, right, and that data is transmitted, let us say, using old MCS information, because that is the best information base station had when it has to transmit the PDSCH, okay, right. So, in this case it might look like that DMRS is redundant, but it is actually not, because MCS was estimated using slightly old channel information, whereas DMRS gives you the instantaneous precise channel information which user can use to decode its data, okay, right. To summarize, okay, SRS is used in this case, in this example which we have considered, is used for estimating the uplink channel, that is step number 1. Once base station has the uplink channel, it knows the downlink channel because it is operating in TDD mode. Now, base station uses that channel to precode the CSIRS, correct. Now, UE uses that CSIRS to estimate the MCS and send it back to the base station, okay, right, done. This is the control information which the base station needed, okay. Now, it will keep this information. If the turn of this user has come for the PDSCH transmission, it will transmit it immediately, otherwise it will transmit it with some delay, right, okay. Now, in order to help the user in demodulating the data, it sends this demodulation reference signal, so that user has exactly the instantaneous channel or the fresh channel, okay. And how does it do? How is DMRS transmitted? DMRS is basically transmitted by using the same precoder which is being used for the PDSCH, okay. So, that it exactly has this channel which it will use for demodulating the data, okay, right. That is the job of DMRS, okay. So, we stop here. Now, in this case, okay, how many, you see this, how many DMRS base station is transmitting? It is transmitting only a single pilot signal from X, or is transmitting a single pilot signal from transmit antenna 1 and the same pilot signal from the transmit antenna 2, right, okay. So, it is essentially transmitting only one DMRS, correct, okay, because it is P and P from both the transmit antennas, okay, right. So, and why it is transmitting only one pilot signal? Because what is norm of H? Norm of H is a single value, right, it is a number, right. So, UE is only estimating a single number, okay. I am making it clear to you because we will use this idea a little later, okay, wherein we will see that transmitter is transmitting multiple pilot signals, okay. When does it do that? We will see that. Okay. But in this case, base station has transmitted only single DMRS, it transmitted only single CSIRS also, right, because in that case also only norm of H was being transmitted. Even in the uplink, right, how many SRS did UE transmit? Only one, right, okay. This was a simple example, okay. When we switch to actual MIMO transmission, okay, we will see that the number of pilot signal actually increase. Okay, we'll discuss all that, but we'll stop here for now. Thank you.